Hello everyone, welcome back to the class. So today's our topic for discussion is VPC, which means Virtual Private Cloud. So what is a Virtual Private Cloud? For example, let's not directly jump into the topic. I'll take an example and explain first. Let's assume you built a house somewhere, like it's a normal house among all the houses. You don't have any security, you don't have any kind of freedom, right? Like you can't customize the houses because no one will accept the change. So for example, you purchased a house at a gated community, then you'll have a lot of security. You'll have a security guard for your house as well as your gated community as well. So when you have a lot of security, like it's your personal opinion, but when we are discussing regarding the topic, most of the companies choose virtual private cloud over random instances, like instances anywhere they run somewhere. They want everything to be organized at a place. So to do that, AWS enable virtual private cloud option to everyone. Actually, they can create a cloud inside another cloud. In a public cloud, they can create a private cloud. So this is what VPC is. Now let's try to understand with help of the same gated community example. I'll share my paint. For example, this is a gated community. You know what? A gated community also has a gate. So through this gate, someone enters and exits, right? For example, uh, there are three communities within the gated community. For you imagine, there are three houses. Okay. Then, as told, each house has another security. So this is the basic setup. And if someone, for example, an intruder or someone, if they want to enter, if someone wants to enter, what will they do? They need to first pass through this gate. Okay, a security checkup will be done, and they will go here, and another security checkup will be done, and they'll be allowed into this house. So let's try to get back into our technical terms. This is a VPC. Let me increase my font size right here. This is my VPC. Can I bring it somewhere? I'm not so familiar with paint, but it's fine. This is a VPC. This whole thing is a VPC, and whenever you create a VPC, you will get a set of IP addresses. How many? Not one or two, but humongous 65,536 IP addresses, which means 256 into 256. So those many IP addresses you'll get along with your virtual private cloud on demand, on request. So those all IP addresses, what you'll do is whenever you create sub projects within this virtual private cloud, you will distribute the IP addresses to these projects. So that distribution concept is called subnets. For example, this certain project got some 5,000 subnets, and this certain project got another 7,000 subnets. It depends on how big size your project is, and this project got some 10,000 subnets, and the remaining subnets will be around this virtual private cloud. So along with, like, these are private subnets. These are private subnets. Let me write down that too. Right here, private subnets. These are all your private subnets, and you'll also have a public subnet here. Let me erase this. we also have a public subnet here. This is a public subnet. So these are all your private subnets and this is your public subnet. Why do you need a public subnet? So let me tell you, if a user if a user with some IP tries to enter your virtual private cloud, so he only can communicate with this public IP. He can't communicate with another things as those are private, as those have separate things. Like this was the only configured thing which the outside request can communicate. They first pass through the internet gateway and they communicate with public IP, and they will have a load balancer here. What is a load balancer? Basically it is also a service which is used to uh, divide the load. If a website has lot of if it got a lot of traffic, then it splits it between two of the nodes, so to balance the things as well as to maintain the server. Let's take a load balancer here. It's not just load balancer, it is elastic load balancer, which means it can upscale and downscale itself, depends on need. So here our request goes to virtual private cloud. First thing, it should cross the internet gateway. I'll write it over here. Internet gateway. So it crosses the internet gateway, then it again crosses our public subnet. Load balancer exists in public subnet. So now the request should go from here to here. Can it go directly? No, it can't go directly because we don't want to expose this IP address. We don't want to expose. So what we'll do is, with help of NAT, we try to mask it. What does masking mean? For example, if a user tries to access this certain EC2 instance, he won't directly access it. He will access it through the IP address of load balancer. So that is where NAT comes into picture. It hides this, it masks this IP address with the IP address of load balancer and then sends back to user. So what user thinks is he is getting a request from this. Even if he tries to hack this, nothing happens because this is private key. Like this won't get disturbed as this controls. So what next? Do you think there will be a direct connection between elastic load balancer and this? It needs to understand the language, right? It needs to understand a medium. So to understand that, actually a route table, I mean, to establish a connection between you and Wi-Fi, you need a router, right? You and internet, you need a router. So in a similar way, it also has a router, but it has a route table. You call it as a route table. It has certain number of IPs and the traffic details. So with help of this route table, let me reduce the font, reduce it to 14, then I'll write it over here. Route table. With help of this route table, you can establish connection between your elastic load balancer and private subnet. So for ELB, which means elastic load balancer, to send request to private subnet, there needs to be a route table, and we have done that. What next? So this is the pathway that a request flows. I think it makes sense. Then what to do? One second. Okay. Yes. So the security, actually, let me tell you about this. In this project, so for this project, you'll have subnets, right? So to these subnets also you'll have another layer called, actually this is the most important layer of protection, which is NACL. You call it as NACL. Okay, I'll write it over here. It is NAC, actually not here. I'll write it somewhere here. NACL. It's fine. This is called NACL. What it does, it provides the protection to the subnets. It provides the protection to the subnets. I mean to say, like, let me take two different examples, as the motto of today's class is to discuss about security groups as well as NACL. So what security groups does? Security group provides security to only the instances which are created within this project. We have seen that in our previous classes we had a security group for the instance we have created. So there will be a default security group for this instance. Let me connect it. So this is the connection. If someone tries to access and if you want to allow, then you will specify a port, right? We have seen that in our example where we allowed port 8000. So the port 8000 then served back to the user, like he could have, then he could access, like he accessed the port 8000 and then viewed our website. So here the major task is, if we want to allow any certain thing, then we can use our security group. So here we have a security group. Here we can allow like port 8000, and default you will be allowed to connect to SSH, which is port 22, and here also you have a security group and same thing. But what if you want to have a common security group to all of these projects, or you think to all of these subnets? So NACL acts as a security layer to the subnet range. Like to the subnet layer only, it acts as a security group. For example, let's take a junior developer or someone, a full stack developer, web developer. You take it, you take him. I'll give him an instance and tell him before only, like you configure a security group so that only specific ports will be allowed. As he will be more focused on the development things, he might not care this. So what he does, he allows the traffic from everywhere. Then what happens? If a hacker found a port open, then he'll go and hack that port. To avoid that, what DevOps engineers do is they go to this NACL and block certain number of ports. They can also block certain number of IPs also if needed. So what is the basic difference between our security group and NACL is, in security group we can only allow a certain port, but in NACL we can allow as well as we can deny a certain port or an IP. So that's the advantage. Like this is one of the way to automate the things, because here by creating a single security group it will be applied to all the subnets. I think the theory part is totally clear to you. This thing should get into your mind because it is the most important concept in AWS, creating a virtual private cloud. Now let's try to do it practically. You'll get more understanding when you do it practically. I'll search for VPC. So on top of this public cloud, we are trying to build a private cloud. So you'll be shown this interface, and whatever we have discussed over here, subnets, route tables, internet gateway, these things we haven't discussed yet. NAT gateway. Yeah, I forgot to discuss NAT gateway actually. Okay, should go to paint, right? So we'll also have a NAT gateway. For example, okay, sorry. Take it as NAT gateway. So what do you think NAT gateway is? What do you think NAT gateway does actually? So and what we have seen a single route, which means a request going to the instance and user can view the website. So what if the website wants to access something from internet? For suppose I gave href equal to youtube.com in HTML, then it should go to uh, Google and fetch youtube.com and bring it over here, right? So if I try to request, I need something called internet gate. No, NAT. I mean NAT. Okay, highlight over here. This is NAT. So what do you mean by NAT? Uh, Network access. Let me search it. NAT. Actually, they call it NAT only. Like, let's try to see full form. Sorry, haven't learned it yet. Network address translation. So that's what you can see right here. To access the internet, one public IP is needed, but we can use private IP. We can use private IP address in a private network. So that's what instead of using the IP which this instance gives us, we are replacing or masking that by the IP of a route table. So that's simple it is. So let's try to work on everything. Okay, here click on VPC, then create VPC. If you click on this button, you'll be shown the whole process which we have discussed earlier. So what does this mean? It means everything gets created by default. So that's the meaning of VPC and more. Along with VPC, these all also get created, which is very simple task. Like it became much easier rather than configuring everything. So we can go with this directly. Here we'll get an internet gateway. Here we'll get a route table. Then here we'll get 4 subnets because we gave 2 regions, right? If we give 1 region, we'll get only a single thing. But let me proceed with 2 regions. Okay. Then here as discussed, we have 65,350, no, 65,536 IPs. If you change, the number might also change. Let me take it as project 1. Then I'll leave everything as it is. Then I'll create this VPC. You see, everything will get created automatically. It's that simple. But configuring everything and doing the things will bring you more clarity. Now what is our aim is, let's try to understand the difference between security group and NACL. First, let's see it. Actually, what all are done, let's take a look. See here, let's consider this as well as this. Okay, I'll consider both of them, then I'll try to compare them. Here what all I got a VPC, then I got subnets. See, public private, I got private subnet, I got public subnet. Oh sorry, I got private subnets, I got public subnet here. Then I got a route table, I got an internet gateway. So load balancer is optional for now and NAT is also optional. Let's discuss when we start doing a project. We got everything I guess except an EC2 instance. Now that's pretty much straightforward process. As you know how to create an EC2 instance directly, search EC2, click on this, then click on instances. If you have any, okay, you better create one instance. You can name it as, what should I name it? VPC demo. Okay, I'll take it Ubuntu, then T2 micro. I'll select a key pair. Then here, previously we haven't discussed or we haven't touched this, we left it as usual, but here it's important to configure, because if we want to establish a connection between our EC2 instance and VPC, as you can see, VPC is somewhere here and EC2 instance is somewhere there. So how do you establish connection? So that's where you configure this. So AWS provides you with everything. I mean, you can select a VPC here, like it gives you a default VPC, but here you have created VPC, right? You should select here. So when you launch the instance, your EC2 instance will directly get connected to VPC. So that's the advantage actually. So default it gave me a private subnet, but here in the image we have taken a public subnet to establish a connection, right? So I'll change it to public one, anything. I'll take this. Then auto sn public IP. I need a public IP, right? Okay, then we have configured it. Then everything will be as usual until we get a requirement. Then launch instance. It will get launched. Okay, my instance got launched. Now what I'll do? Let's try a demo. I'll try to expose this port, but to expose something I need to install a software or something, right? Let me try to do that. I'll connect to Mova Xterm. Session SSH. I'll paste this. I'll specify username called Ubuntu. Then advanced settings. Use private key. I have it already downloaded. Okay. Click on OK. Okay, it got connected. My first command sudo apt update to fetch all the latest updates it has. Done. Done. Then let me try to expose my Python. Like if it is installed, it will show where my Python is installed. Python 3. Search for it. Okay, it's my latest version. I have Python. I'll exit this terminal. Okay, now I have Python installed. I'll try to set up the root. Python 3 -m http dot server, and I'll give a port 8080 or 8000 something. So it will run on this port. Now let me try to see. This need not be the exact port. Even if you copy paste this won't run exactly. Let's try copying this, opening it somewhere here. You know, right? We haven't configured anything in our security group yet. So I'll give 8000, and you know it won't do anything. I need to configure my, where is it, security to allow inbound traffic for TCP, which means anyone who is accessing this should be displayed, means it should be available on internet and everyone should access it. Then I'll edit this. I'll edit the inbound rules. What should I do? I'll add a custom TCP. And what's my port? 8000. Then I keep it this. Then I'll save the rules. So it got modified and everything, yeah, everything takes within seconds to get updated. So you can see this, right? In my Python, these are all the directories and I have nothing installed except Python. So this is being shown. Very nice until now. So let's come back to this image again. So what I did, I haven't yet specified an NACL. So what I created an EC2 instance, I connected it with a security group. What next? Previously I haven't configured, so it didn't allow. So here I configured and it showed me what I wanted to see. If you can see here, it shows 200, which means a success note. That's it. See here, you have your EC2 instance and a security group connected. But let's try to connect an NACL. Let's try to see NACL. I'll search VPC. I'll open it in another tab. Okay, it opened in new window. Then I'll go to network ACLs, which means NACL. Then I'll configure it. Like, let me check if everything is perfect here. If everything is working fine, I'll go here. Actually, see here, it gave us two inbound rules, which means rule 100, you leave this number, but what this rule says is my NACL accepts traffic from everywhere, which means here when we are trying to access this, NACL didn't stop, so we were able to connect. Even though we deployed in VPC, we were able to connect. But what if I make use of exact VPC settings? Let me try to do that. I'll do that now. So now what I'll do is, we have exposed our port 8000, right? I'll exactly block that port and see what happens. See, I will give custom TCP and port range 8000. So here it is allow, it's well and good, but I'll keep deny here, then I'll save the changes. And you know, within seconds, no latency, that's a specialty of AWS. I'll refresh it and you'll find nothing over here. Of course, you'll not get anything here. See, it got stopped. Why? What's the reason? It is running when everything is fine, when this is also allowing, but once we stop here, even the security group is allowing, this won't allow. So the user here will get his connection terminated in between, which means he can't connect to instance again until and unless that port is specified. So that's the exact functionality and the exact difference between security group and NACL. Hope it is clear to everyone. So I think everyone is clear about how to create a virtual private cloud, if not completely, at least until the class which we have learned today. I hope that makes sense. Yeah, and that's for today. Let's come up with a new topic again tomorrow or the next day. So thank you everyone. Thank you so much. So bye all, have a great day.